Thanks, everyone. That was really useful. Oh, well, you're seeing the words at least. Right, liquids can flow, the similarities. So basically, you get achieved, you're listing the similarities, and to get merit, you're looking at the differences. Thank you for informing me 20 minutes in that there was no sound. Okay, brilliant. Oh, well, never mind. Final question then for this is part D. So the sun's power is 1.3. Okay, so we've got power 1.3 times 10 to the 9 watts. Heats up an ice cap of a mass of 10.5. So we've got a mass there. And 65% of the sun's energy is being reflected. So calculate how many days it would take. So we've got time to melt the ice cap, and you've also got a latent fusion. So Q equals ML would be potentially in there. Okay, brilliant. Oh, well. Anyway, so in terms, so that's the question we start off with, Q equals ML. So Q, which is going to be the heat, will equal, we get back to the answer. So our mass we get from the question. So it's 2.5 times 10 to the 8 times the latent heat, which is 330. So these numbers you'll get in the exam, so it shouldn't be a problem. In that regard, it's just about choosing the right equation. So that's 8.25 times 10 to the 13 joules of energy. Okay, so that's basically your latent heat. Okay, and then we've got an efficiency question because you've got 65% of the sun's energy is being bounced back. So that means only 35% is being absorbed. 100 minus 65 is going to be equal to 35 is actually being absorbed by the ice cap. Okay, so the power will be 35% of this number here. 35% times 1.3 times 10 to the 9. Okay, so 35% is 0.35. You just plug in the numbers. I might move that down slightly. And that will be 4.55 times 10 to the 8 joules is how much energy or power is actually being absorbed. Okay. And then from our previous question, E equals P times T, where Q is the same as saying energy, because basically Q is heat energy. P times T. So do the numbers. That means that T, if you rearrange the equation, will be Q over P. In this case, which is the same as E. So plug the numbers. We've got the Q above here. That's your Q. So there we go. 8.25 times 10 to the 13 divided by the power 4.55 times 10 to the 8, which equals, wow, a big number, 1.81 times 10 to the 5 seconds. And the question, I think, says put into days. Yep. Okay, so how many days is 1.81 times 10 to the 5 seconds? So you go 1.81 times 10 to the 5 divided by 3,600 to convert it into days. Oh, actually, no, that's hours. Equals 50.4 hours over 24 to get into days. So it's going to be equal to 2 days, roughly. Takes 2 days to melt the ice. There we go. That's question number 2. So now we can all hear each other. If you've got any questions, yeah, be sure to put it into the chat. Good start to this tutorial. Yeah. So the last question is question number 3 around the hand sanitizer. So Tim wants to learn about hand sanitizer, how it works. So basically, hand sanitizer, if you don't know, is about 75%, 70% alcohol in a ethylene glycol matrix. So calculate the heat energy required to evaporate. So we've got heat energy, 5 grams, a latent heat. So again, we're using our crusty equation from the last question. Q equals ml. So it will be, it's given in joules per gram as well. So 5 times 879, which equals 4,395 joules. And that's going to be your achieved point there. Just plugging in the numbers. Okay, so in physics, we kind of like those achievement questions where you're just plugging in numbers. Right, so Timo finds that the hand sanitizer contains 60 to 90% of alcohol to be effective, as I just said in the previous question, about 80%. This gives enough time for the alcohol to cool off the bacteria, and also from a bit of biology, about 75% gets into the cell through the cell wall to actually get into the nucleus. If it's too high, it can't do that. The most effective has a concentration of 70, just as I said, mixed with aloe vera gel. Yeah, which is kind of your matrix. Explain using the graph below why the latent heat of vaporization of a hand sanitizer goes down as the percentage of alcohol by mass goes up. Okay, so why latent heat of vaporization goes down as the percentage of alcohol goes up. So basically, as the alcohol concentration goes up, the percentage of water goes down. Okay, so there's more alcohol. There's as percentage alcohol goes up. Makes sense, because if you've got more alcohol, there's less water there as well. So 70% alcohol, 30% water. Okay. The latent heat of water is higher than alcohols. Okay. And so therefore, and that's what therefore is, those three triangles, more alcohol, less latent heat. Yeah. Okay, so achieved is 1 point, and if you have 2 or more points, then that's going to be your merit. And part C, Tim puts some hand sanitizer onto his hands and rub it around. Okay, so it feels colder. Use a table below. Specific heat capacity, latent heat of evaporation of an isopropyl alcohol to explain why Tim's feels cold. Okay, so water specific heat capacity, as was said in the previous question, is higher than isopropyl alcohols, and same with its latent heat of vaporization. It's a lot larger than isopropyl alcohols. Okay, so that's basically what we're stating. So to get the achieved points, you're basically stating the facts. So you just say that water, higher specific heat capacity, and latent heat of vaporization. Okay, that will get you your achieved. It's just stating simple facts. Okay, to get the merit, you're then linking the ideas. So a lower latent heat of vaporization, less heat required to change state. Okay, so that means that because isopropyl alcohol has a lower latent heat of vaporization, then it's going to basically require less heat energy from the hands to change from a liquid into a gas. Yeah. Okay, and oops. As the alcohol heats up, it takes energy or heat, I'll make it specific, heat energy from your hands. That's why it's colder. Okay, so basically as the liquid alcohol changes from a liquid into a gas, that requires taking energy from your hands, heat from your hands, and that's getting lost with the alcohol evaporating. And that's going to be so that's an achieved, that's going to be your merit, and that's going to be your excellence, those 3 points there. Okay, so hopefully that makes sense. If it doesn't, leave a comment in the chat. Okay, so last question. Tim needed to use his hand sanitizer in his car. Okay, when you open the plastic container, all the hand sanitizer gushed out. So explain, again, using kinetic theory of matter, so you should be revising that before Friday, why the hand sanitizer gushed out. Okay, so as the sanitizer heated, it went from being a liquid to a gas. I'm thinking. Yep. And it's heated by radiation from the sun. Okay, so radiation from the sun heated it up. Yep, so heated liquid to gas. This heated up the liquid particles. They expand into gas particles. Okay, and it's those expanding the gas particles as the gas particles expand. When you open up the container, it's then going to, that pressure is going to build up and it's going to explode out. So there we go. That's 2022's paper for level 1 physics describing heat. So is there any questions from the audience after I stop sharing? There you go. Okay, any questions from the audience after our wonderful can't hear anything beginning? Do you want me to go through those early questions again, or are you all good? Okay, so if there's no further questions, good luck for Friday. I remember to attempt all the questions, give it a shot. There's only 3 equations you really have to know, and just try and answer all the questions the best you can do, and all the best for the exam. Okay, awesome. Okay, so Ngāhi nui for joining me, and all the best.